All right, the next couple sections look at something that's actually very important for algebra, and that's looking at something called factoring. Okay, so we're starting out kind of with something basic, and that's factoring out the GCF. So this stands for greatest common factor. So this is like, what expression or what polynomial can I pull out of the entire expression? In other words, all the terms in the expression have to be divisible by this greatest common factor. So if you look at number 1 here, looking at both of those terms, I see 2 and 8 are both divisible by 2. So pulling that out would leave me with x plus 4. So in this case, the GCF, the greatest common factor, is 2. And here's my expression written in factored form. If you look at number 2, I'm going, what can I pull out of the entire expression? Well, both terms there are divisible by that factor of x. So if I take that out, I'd be left with an x minus 3. You can always think about distributing back through to check these. That'd be x squared minus 3x, right? So in this case, the GCF is x. Here's the factored polynomial. Well, this one's more interesting. Okay, let me look at the constants first. So what are both 8 and 12 divisible by? 4. Okay, now let me look at the x's. So what can I pull out of both x cubed and x to the 5th? It would be the lower power, right? X cubed. What about the y's? Okay, those match, so I can take that y squared out. So here, this guy is my GCF. So that whole 4x cubed, y squared. So what does that leave me with? So now I'm looking at the first term here. I'm going, okay, so let's see. If I take that 4 out, that'll leave me a 2. I took an x cubed and a y squared out. So that's it. Now let me look at the next term. Okay, I took out a 4, that'll leave me a 3. Let's see, I took out an x cubed, that'll leave me an x squared, and I took out the y squared. So that'd be it. Now you can always check that, again, by distributing. So let's see what that would look like. That'd be 8x cubed y squared plus 4 times 3, 12 x to the 5th y squared. Is that what we started with? Yes. Okay, what can I take out here? Well, all terms are divisible by 2, but when we have this lead negative, we typically pull a negative out. So if I pull that negative 2 out, I basically have to change all the signs here. So think about distributing this through. I'd have negative 2y squared. Negative and negative makes positive 10y minus 14. Okay, let's see. Here's another more interesting one. So let's start with the constants. So we've got 5, 10, 15, and 45. So those are all divisible by 5. Now I'll look at the powers of x. So the lowest power of x is going to be what I can take out of the whole expression. That's going to be squared, x squared. So what does that leave me with? Well, if I pull out the 5x squared, that whole first term just leaves me with a 1, right? Because 5x squared times 1 is 5x squared. Okay, what about the next term here? So I pulled out a 5, I'm going to have a 2, and then an x squared. Okay, what about the third term? It's a negative. 15 divided by 5 is 3, and I'll be left with an x. Okay, 45 divided by 5 is 9, and I pulled out a squared, so I'll be left with an x cubed. Okay, so there's my answer, and then I try checking what'll happen if I distribute. Let's see. 5x squared plus 10x to the 4th minus 15x cubed minus 45x to the 5th. And then making sure that's what we started with, it is. So that checks. Here's an interesting one, because here's the GCF. You see how that factor of a minus 5 matches in both terms? So actually what I'm going to do is I'm going to pull that a minus 5 out of the whole expression. So what will that leave me with? An a plus a 6. So there it is in factored form. So actually, this is the GCF, the a minus 5. Now think about if I'm going to check this. This is kind of an interesting one to check. Okay, so how would this work? So I'd take this a minus 5 and I would distribute it. So I'd have a times a minus 5, and then I'd have plus 6 times a minus 5. Oh, that's what I started with. Same thing for this one. See how I have that GCF of x minus 1? I'm going to take that greatest common factor out. What am I going to be left with? An x squared plus a y squared. So here's my GCF. And then let me just check it again. Okay, so how does this work? I take the GCF and I distribute. So I'd have x squared times x minus 1 plus y squared times x minus 1, which is what I started with. Okay, so these guys are a little bit different. So with these ones where I have 4 terms, typically we use a process called factoring by grouping. So when I see 4 terms, I kind of think, well, I may want to use this process factoring by grouping, because you see, if I look at the whole expression, there's actually not a GCF that I can factor out of that whole thing. So then I think instead, well, what if I try grouping? In other words, what if I try putting these first 2 terms together, thinking of those as a group, and then the second 2 terms together, thinking of those as a group? Okay, so I look at the first group, and I say, what can I pull out of that first group? I can pull an x squared out of that group as a GCF, right? Then I look at my second group and I say, what can I pull out of this second group? Well, a 5 or a negative 5, but remember when that leading sign is a negative, we typically pull a negative out. Before I do anything else, look, check these. This would be x cubed minus x squared. Then I'd have minus 5x plus 5. That's what I started with, right? So all I'm doing here is thinking of the first two terms as a group and the second two terms as a group. Because once I've done that, then I can factor out that x minus 1 and be left with my x squared minus 5. And then I have it factored. So I think for number 9 here, I would do the same thing. I see 4 terms. Nothing can come out of the whole expression. So instead, I would try grouping the first pair and the second pair. So from the first group, I can take out a z squared, leave me a z plus a 4. Second group, I can take out a 3. Then I can take that z plus 4 out of the whole expression. Now another way you could check this is you could do a FOIL. We talked about that. That'd be z to the 4th plus 3z plus 4z squared plus 12. Does that match the original expression? Where did I get z to the 4th? No, it doesn't match, but I think I made a mistake. So looking back at my foiling right here, see what I did. Let me double check running through my foiling again. See if you can help me find the mistake. Z times z squared, this should be z cubed, shouldn't it? Let's see then, plus 3z plus 4z squared plus 12. So let's see if it matches. Z cubed, 3z, yes it does. So it does check. So here's my answer, right? The factored version. This here is just checking. Okay, again, 4 terms. Nothing I can take out of the whole expression. So let's take a t squared out of the first group, 2t minus 1. And then a negative 2 out of the second group. Let's check at this step and make sure we got that right. So that'd be 2t cubed minus t squared minus 4t plus 2. That looks correct. Okay, now I can take that 2t minus 1 out as a GCF, greatest common factor, and I'm left with t squared minus 2. Should I try foiling another one here to check? Let's make sure I get it right this time. 2t cubed minus 4t minus t squared plus 2. Is that what we started with? Yes. Okay, how about 11? Okay, nothing can come out of the whole expression. So I group. First group, I can take out an n as a GCF. Second group, I can take out a 2. Then I can take the m minus 3 out, and I'm left with the n plus 2. To check, let's see, I have mn, 2 m's, minus 3 n's, minus 6. And looks good. All right, first thing I noticed with this one is I actually do have a GCF I can take out of the whole expression. I can take out a 10. So that means I'd want to do that first. So should I make a note first, always check for overall GCF. Because if there's a GCF overall, I always want to take that out first. Then let's see, so I'd have a 3xm. Oh, I can't do 10, can I? Because 15 is not divisible by 10. But I could do 5. So let's try. Let's try it again. 5. That'd be 6xm plus 3xn minus 4ym minus 2yn. So you notice as I go along, I'm always checking these steps as I go. That way I can catch small mistakes like that before I go through the whole problem. So checking so far, I'd have 30xm. I'd have 15xn. I'd have minus 20ym minus 10yn. So that's good so far. So then I continue. Okay, so then I'm going to look at my groups. First group and second group. Okay, from that red group, looks like I can take out a 3x. So that leaves me with a 2m plus an n. From the blue group, I can take out a negative 2y. That leaves me with an m plus an n. Let me just double check that step. So let's see, that'd be 6xm plus 3xn negative 2ym. I think I see another mistake. And because I should have a negative 4 here. So again, that's why I'm checking these steps as I go. It should be a 2m. My plus an n. Okay, let me keep checking now. Now I have minus 4ym minus 2yn. That looks correct. Of course, I have my 5 in front. Everything matches. Okay, then continue. Okay, so then now I can take my GCF out here. So that's 2m plus n. And what does that leave me with? 3x minus 2y. And there it is in factored form. So that's a nice complicated one. That's the last one, so I don't know, should we try checking it? So I'd start with doing the FOIL here. So I'd have 6xm minus 4my plus 3xn minus 2ny. Then distribute the 5. 30xm minus 20my plus 15xn minus 10ny. So that is indeed what we started with. So this looks like a good answer.